Okay, so in today's class we will going to read about the construction of SHA-1. So secure hashing algorithm 1. So here in this SHA-1 it's of 5 steps. It's of 5 steps. So here in this SHA-1, that is secure hashing algorithm, will going to accept a plain text. So the plain text should be of less than 2 power 64 bit. So the output what we will going to give is the output of message digest, which is of 160 bit. So the SHA-1 will going to accept an input, a plain text with which is less than 2 power 64, and it will going to give an output is MD, that is message digest. The output will be of 160 bit. So here in this step 1, what I will going to do is, in step 1 I will going to append pad bit. So you guys know already what do you mean by a pad. Pad is nothing but an adding. So in step 1 I'm going to pad the bit in such a way that padding bit should be a multiple of 512. So that is multiple of 512 means 512 into 1 will be 512. 512 into 2 is 1024. Like this, the padding bit should be a multiple of 512. So in your computer networks, that is in cyclic redundancy check algorithm, we are using padding bits simply as zeros, whereas in SHA-1 algorithm we will going to pad 1 followed by the remaining zeros. Okay, so one more condition in this SHA-1 is, so here we need to add 448 bits, up to 448 bit, and if I mod with 512 it should going to give 64. So this is remaining 64 bit. So that means if my message consisting of suppose around 300, I need to add 148 bit more in order to make 448, and we should be remain 64 bit. So in step 2 what I will going to do is, in step 2 we will going to pad the length, that is the padding length. So the remaining 64 bit what we have left out, we will going to use it here. So 64 plus 448, which will going to make 512. So in first step we will going to append a padding bit, so in such a way that it should be equal to 448, and the remaining 64 bit we will going to append in my step 2, that it as a padding length. So totally put together we will going to make 512. In step 3 I will going to initialize message digest buffer. So initialize message digest buffer to hold final digest value, in order to hold final digest value. So the size of this final digest value is 160 bit. 160 bit. So we need, in order to hold this 160 bit, we need 5 registers. So those registers I will going to name it as A, B, C, D and E. Each of these register will be having 32 bit. Each of these registers will be having 32 bit. All put together, if you add all these 5 put together, we will going to get 160 bit. So each 32 bit can be of any hexadecimal value. Can be any hexadecimal value. So this is about step 3. So in step 4 what I will going to do is, so in step 4 what I will going to do is, so in step 4 there will be of 4 rounds and 20 steps. So 4 rounds, I will going to tell what do you mean by these 4 rounds. First we will going to have a primitive function f1 followed by a constant value k1 with a word which is of 0 to 19. So 0 to 19 means there will be a 20 word. So this will be the first round. So this round will be having 20 steps. So in such a way that W word 0, word 1, word 2, word 3, word 4 up to word 19 will going to have 20 steps. So this is my round 1 with 20 steps, and my round 2 F2 comma my constant value K2 with a word remaining 22. 20 means it will be around 29, and my step 3 is F3, my primitive function F3, constant value K3 with the word 40 to 59, and my F4, my fourth round F4 with a constant value K4 with the word 60 to 79. So there are 4 rounds, and each round consisting of 20 steps. So each round consisting of, I am writing with a single and ends and scribbling these diagrams. So 4 rounds, so totally it will be of 512 bit. So this 512 will be divided among these 4 rounds, of which is of 128 bits, 128 bit, 128 bit, 128 bit, and this rounds will be having a registers, the 5 registers what we have been initialized previously, A, B, C, D and E. So each of these registers will be having 32 bit, 32 bit, 32 bit, 32 bit, 32 bit. So this 32 bit will be processed further. And 5. So whatever the output we are going to get here will be processed in my step 5. So the addition, so whatever the output we are going to get here will be 1, and plus the input what we are going to get, what we are going to give will be the final output. This is how the SHA-1 works. I hope you guys have understood. Thank you.